Hello friends, I am Professor K.S. Tanpure from Zeal College of Engineering. I am here to discuss with you some of the important topics from subject called physics. Let me introduce to you today's topic of discussion, that is Doppler effect. But you must know this Doppler effect comes in chapter named wave motion. Now let us start with the Doppler effect. Before starting into this Doppler effect concept, let me ask you one question. Have you ever heard an ambulance passing by and its pitch changes? Now why this happens? The answer is there in the Doppler effect. So in order to study this Doppler effect, we must know its principle, we must know the basic information about CA Doppler. Then we are going to explain this Doppler effect using certain examples, and the last part is the application of this Doppler effect. So CA Doppler was a great physicist and mathematician from Austria, and this Doppler effect was named after him. Now what is there in this Doppler effect? According to him, he did many experiments and drawn some observations from that experiment. According to him, when we have two objects, that is, one is source, another is observer, and if they are moving with respect to each other, there will be change in frequency as well as there will be change in the wavelength. So the principle states that the apparent change in the frequency of sound due to relative motion between source and observer is nothing but a Doppler effect. Let us discuss this using some example. Now you may find three cases on the board. One, initially let us consider source and the observer both are stationary. So you may find in the diagram, one is source, one is observer, and both are stationary. That means there is no movement of source towards the observer or observer towards the source. So the source, consider the source as a ambulance van. It is stopped at one place and it is blowing the siren. Once the siren is blown, you may find the waves are generated, and whatever the waves are generated, that get passed to the observer. You listen the pitch of the sound, and the pitch of the sound remains constant. Now if you take a second case where source is moving towards observer. Now this is your second case. Now what does it says? As the source moves towards the observer, then you may find whatever these waves are generated, the lambda, that is we call it as a wavelength, gets compressed as the source moves towards the observer. Once the source moves away from the observer, then again you may find the wavelength changes. That means if the source is moving towards the observer, the waves get compressed, that is lambda gets decreased and the frequency increases. While as the source moves away from the observer, you may find the lambda increases and the frequency decreases. So you may find as the ambulance moves away from you, the siren's pitch becomes very low. That is nothing but your Doppler effect. So you must know what is lambda, you must know what is time period, and you must know the frequency. So if we draw a wave on displacement versus time graph, you may find lambda, that is we call it as a wavelength, is the distance between the two crests or two troughs, or you may say peaks of the two crests or peaks of the two troughs. The frequency is nothing but number of waves that are generated per unit time is nothing but your frequency. Now what is time period? Time period is the total time taken by the wave to complete one cycle. So these are the fundamentals of wave. We were discussing about the source moving towards observer, source and observer when both are stationary, and the third case, that is observer moving towards source. Now this case is vice versa of this case. Let us discuss this mathematical expression. Now what is NA? NA is apparent frequency, V is the velocity of sound, VO is the velocity of observer, and Vs is the velocity of the source. Now let us discuss this mathematical expression using these three cases. Now initially this n is the frequency of sound that is generated from that particular ambulance. Now apparent change in the frequency, if you take an example as source and observer, both are stationary. If both are stationary, VO and Vs will become 0. In second case, if the source is moving towards the observer, that means the observer is stationary and the source is moving. So VO becomes 0 and Vs increases. So in that particular case, I have shown one positive, one negative sign in the numerator, one negative, one positive sign in the denominator. So for this particular case, you have to use this formula, that is apparent change in the frequency is equals to velocity of sound plus velocity of observer divided by velocity of sound minus velocity of source into n, that is velocity, that is frequency of sound generated from that siren, where VO becomes 0 as observer is stationary. That means V, that is in the numerator, becomes high and in the denominator it becomes less. Therefore, there will be apparent change in the frequency. That means if lambda decreases, then frequency increases. In the third case, when the observer is moving towards the source, during that particular case, you have to use another formula, that is NA is equals to V minus VO upon V plus Vs into N. So in this case, you may find the observer is moving towards the source, that means source is stationary. So the denominator part will become 0, Vs will become 0 and VO will have certain value. So V minus VO, that means the numerator will be less than that of denominator and you will find change in the frequency. So the bottom line of this particular Doppler effect is, as the lambda increases, there will be certain decrease in the frequency, or when the lambda decreases, there will be increase in the frequency. Now the last part of this particular Doppler effect is the applications. This Doppler effect can be used to determine the speed of the vehicles. You may find a traffic police having velocity guns with them to determine the speed of the vehicle. If the vehicle speed goes beyond certain limit, then it initiates the alarm.